Hello and welcome to this Edexcel Further Math Statistics video. This time looking at hypothesis testing with the geometric distribution, and please note that this is part 1 of this particular video. So first of all, here we have a reminder of the definition of the geometric distribution, and you should have worked with the geometric distribution in the DRV6 section. So you might want to pause for just a moment to remind yourself of this definition. So you should have met the concept of hypothesis testing within your studies of A-level maths. We're going to be looking specifically in this video at hypothesis testing with a geometric distribution. So if we have a random variable that's distributed with a geometric distribution parameter p, we could be testing null hypotheses of the form p equals 0.15. So could the probability of a success in the population be 0.15, or is that not feasible? And remember, all calculations when testing that null hypothesis will assume that what we are stating in the null hypothesis is true. And then our alternative hypothesis, H1, is what we're going to conclude is likely to be true if the null hypothesis is rejected. And remember, just as before, tests can be one or two-tailed. So it's probably worth pausing for a moment and just running through this procedure for hypothesis testing, just making note of all the different steps that it's necessary to follow. And do remember that there are two different ways of carrying out this procedure. We can either find a critical region or we can examine a p-value. So if you just read through this example here and perhaps pause and just think about what hypotheses you would think need stating here, and also what significance level we're talking about. Obviously we're being told something about a defective rate, so a probability being 5.5% or 0.055, and we're being given some information about something that has happened, and from that information we're going to carry out a hypothesis test at the 10% level of significance. So to formalize that information, we are testing p equals 5.5% against p is less than 5.5%, because we're being asked to test at 10% whether the defective rate has in fact decreased. And the information we have to use for testing this is that the first defective product was found on the 48th sample. So we obviously had 47 samples that were not defective. So is there any evidence at 10% to suggest that our probability of a defective has decreased? So our test statistic is coming from the fact that we know that the first defective product happened on the 48th sample. So for our solution, now we've got all the information summarized here, we either need to look at the p-value method, which is what we're going to be looking in part 1 of this video, or we need to be looking at the critical region method. So this video will focus on carrying out this test, the p-value method. So we're not going to look for the critical region, we're going to look for the p-value, the probability that the event that we know occurred or something more extreme could happen. So this is the required calculation to find the p-value. We need 47 non-defective products to have occurred to find our first defective product on the 48th sample or beyond that point. And therefore we need 1 minus p to the 47 or 0.07. And from that we are going to have to think what conclusion we should make. And considering our 10% significance level, or our alpha, clearly 0.07, which is our p-value, is less than this 10% significance level for our one-tailed test. So we're going to reject H0 in this case, and we're going to say there's significant evidence to suggest that indeed the defective rate has decreased from 5.5%. And in the next part of this video, we'll examine carrying out this hypothesis test looking at the critical region method.